This video shows how to find local maximum and local minimum values of functions. So let's consider the function f of x equals x squared times e to the x. First, we're going to talk about critical values. So what are critical values? Critical values are the values of x such that the derivative of that values equals 0, or the derivative of that values is undefined. And we know that local extrema, which is local minimum or local maximum values, only occur at those critical values. So maybe the first step is we want to find the derivative of the function f of x. F of x is x squared times e to the x, so the first derivative of f of x equals 2 times x e to the x plus x squared e to the x using product rule. And then if we want to simplify or combine these two terms, we can factor the x e to the x out, and left over inside the parentheses is 2 plus x. Second, once we have the first derivative, we can find the critical values by first setting the first derivative equals 0, which is x e to the x times 2 plus x equals 0. And we can find that the values for x have to be either x equals 0 or x equals -2 for this first derivative equals 0. Then we want to check if there's any values of x such that the first derivative is undefined. It turns out that the first derivative is defined everywhere. So there's only two critical points, critical values, which are x equals -2 and 0. So first we want to use the first derivative test to find the local maximum and the local minimum values of the functions. How can we use the first derivative test? So the first derivative test says if the derivative function changes from positive to negative at a point, critical point C, then C is a local maximum point. And if the first derivative changes from negative to positive at a critical point C, then C is the local minimum point. So now we can populate a table to determine whether a critical point is a maximum point or minimum point using the first derivative. First, we come up with the domain of the function. So the domain of the function is from -infinity to positive infinity, and then we add the two critical points, which is -2 and 0, into this domain. And using these two critical points, we divide the whole domain into 3 different intervals, which are -infinity to -2, -2 to 0, and 0 to positive infinity. And then we're going to use a test point for each interval. So I use -3 in this interval, -1 in this interval, and 1 in this interval. And then I'm going to evaluate the first derivative at this test point, f prime of -3, f prime of -1, and f prime of 1, to find the sign. So I found that f prime of -3 is positive, f prime of -1 is negative, and f prime of 1 is positive. From this test point, I can make conclusions about the behavior of the function f of x on this interval, -infinity to -2. Since the derivative of a test point is positive, I know that this function is increasing on this interval. Go to the next interval, 2 to 0, since the derivative at the test point is negative, then this function here is decreasing on this interval. And I know that on the interval from 0 to positive infinity, the function is increasing because the derivative is positive. Okay. So now if we use a first derivative test, the derivative is changing from positive to negative, then at this point is -2, then -2 is the local maximum value of the function f of x. And then the derivative is changing from negative to positive at the point x equals 0. That means x equals 0 is the local minimum of these functions. We can take a look at the graph of the functions, and you can see it clearly at x equals -2, the function achieves a local maximum, and x equals 0, the function achieves a local minimum value. Also, we can use a second derivative to determine whether a critical point is a maximum or local minimum value. How to use a second derivative test. So if c is an open interval, be a critical values, and then the second derivative of the function is defined on this interval I, then if the second derivative value at c is positive, then c is a local minimum value. And if the second derivative at c is negative, then c is a local maximum value. And then if the second derivative at c equals 0, then the second test fails, but you can always use a first derivative test. So now we should find the second derivative to determine the local max and local min. So the second derivative is just the derivative of the first derivative, and this is the first derivative. Then the second derivative, again using the product rules, we can find the second derivative of these functions, and then you can, from here, you can factor each of the x out, and the leftover is this polynomial x squared plus 4x plus 2. So this is the second derivative of the functions f of x. And reminds ourselves that our critical values are x equals -2 and 0. So if you plug -2 into the second derivative functions, you get e to the -2 times -2, which is negative number. So you know that when x equals -2, is a local maximum. Similarly, if you plug 0 into the second derivative, you get positive value. So then 0, x equals 0, is a local minimum. And here's the pictures of the functions again, just to make sure that we got the right answer. So at x equals -2 is achieve a local maximum, when x equals 0 is achieve a local minimum value.